Hi everyone, welcome to our fifth STEM session in the Girls Code It STEM session series. This one will be on Python libraries, and we will cover what exactly is a library, how and what they're used for. I will show some basic shapes, how to do them in vPython, and we'll end with the bouncy ball in a box tutorial. I'm Simone. I'm the Director of Education, one of the Directors of Education for Girls Code It, and I'm really excited to share this information with you. Please subscribe to our channel, make sure you come to our classes, and without further ado, let us begin. What is a library? So, a library is actually pre-made code that can be imported to avoid repetitively typing it out. If you think about it, if you have a lot needed to type out, so if you have a program that is very long, you don't want to keep typing out the same code so many times, especially if it's a long piece of code that someone could have already made for you. So if it's a basic function, like maybe making an image, you don't want to type all of that out. Someone would have already made it for you, which is what libraries are. They offer an easy and less time-consuming way to accomplish important tasks. Currently, there are 137,000 Python libraries. Python is such a commonly used language that there are so many libraries because libraries are so useful. So it's no surprise there are so many. Python libraries and libraries in general can help with machine learning, data visualization, image manipulation, and a lot more. Today we'll be going over 3D imaging, how to put how to how to demonstrate images in Python, but most commonly Python is used for this data visualization and manipulation. And if you guys want to look into that, I would recommend watching our past two STEM session videos that were on an intro to data analysis and on a data analysis demo project. And commonly used Python libraries include NumPy, TensorFlow, and vPython. And there are so many more, but these are the ones that I have heard a lot, so I assume you guys have heard them a lot. But NumPy is a data visualization one, TensorFlow is used for deep learning, machine learning, and vPython, well, they're used to help with that. And vPython is used, as I said, for 3D images and animation. Okay, let's get started with our Visual Python. So, Visual Python is a Python package for 3D animation and design. Since Python doesn't have a built-in 3D visualizer, Visual Python really helps with that. That's why it was created in 2000 by these men, and they were very helpful since this allows us to make images in our code using code. If you think about it, if you're creating something like a game, the user will be really bored if it's just text that they have to input and then it spits out something. It is much more engaging if you have images, and that's what vPython will allow you to do. But so for installing, here I'll go into the vPython demos. So to install vPython, you can follow these instructions, and this is for vPython 7. This document is geared toward that, but I've installed vPython 9, which is a little bit different, which is why some of these commands are a little bit different. So just pay attention to that. Make sure you look into that before typing your commands. You might get frustrated and then realize that it's just not the correct version. But in Terminal for OS, you type this, and then in CMD in Windows, you can type this. In both ways, you'll get it, but the way I'd recommend is I will demonstrate, and these are the demos we'll just be using, but if you go to this website, and I will link this website in the description, you can download Python from here, and then download vPython. And of course, you need Python first before downloading vPython. So these two, make sure to follow these instructions, and here it has them for a variety of different systems, and it'll take you to this website. Just download it, make sure they're safe. You've downloaded the entire file, and then you can start using, and this will pop up, this little icon will pop up, and you can start using vPython. So without further ado, let's get to the demos. So I will be going first over some basic shapes, and I'll do this mostly here, but the first thing you want to do is type this line. This will allow you to import all of these functions instead of having to import them separately. If you don't do this, none of this will work. You have to make sure that you import them. Asterisk basically means that you're importing every single function that is used in this library. You can import them separately, but that takes so long. It's much easier to just import the whole thing. If you want to import like arrow, then import box, that just doesn't make sense. Just import them all. It'll be way faster, way more efficient, and you will spend less time with it. So I will begin with our arrow. So what this is, it's basically, libraries are basically just a set of functions and that can include all these different attributes to draw out these shapes. And the position attribute, and there's so many different attributes, I will link a website that will go through many more than I will ever be able to go over in a presentation. But for now, I'll show you guys the basics. The position defines the starting point, so where you want your arrow to be drawn from, and that is 0, 0, 0. And all of these quantities are in the x, y, and z planes, and it's just a vector that you have to add it, and you'll see where it is. So we start from 0, 0, 0. You guys can start from somewhere else. This is just easiest to view for me, but you can start from 0, 0, 0, and here we want to comment this one. I was working with it and uncomment the arrow, but you guys start from 0, 0, 0, and to run this, you can press run and click run module, or you can just press F5. I find that to be easier. The axis will give it the direction that it wants the arrow to go in, so it starts from 0, 0, 0, then it goes in a certain direction for a certain length, which is defined here. The default value for length, if you don't include this, it's no biggie. It'll just default it to 1, so your arrow will have a length of 1, and the color will be green. Well, I said it would be green. You can change it to a different color. Here I've tried to include all the possible colors that can be used in vPython, but for now let's make our arrow green. We click F5, and we get this. We have our arrow, it starts from 0, 0, 0, and it goes in the axis direction. And there's so many different attributes. You can make the width of it to be different, you can make this top part to be different. So many different things you can do with this. But for now, let's focus on this. So here it starts from 0, 0, and I just want to show how you can rotate. To rotate, you can press the Shift key, the right mouse key, and then just move around. And that is how you can rotate your arrow. To zoom, you can press the Alt key, ALT, the left mouse button, and just drag your mouse forwards and backwards. We X out of that. This is the Python shell that I showed a little bit before. It runs your program. Let's comment this and move on to our next shape, which is a box. And a box is really useful. It is going to be used in our bouncy ball in a box tutorial. But for a box, you want to define its starting position. So it starts, the center is at 0, 0, 0. Then its axis, the way it's going to extend outwards towards, is this vector 1, 0, 1. You can change these, of course. All of these values I've just set to values that popped into my mind. But except these are 0, 0, 0, I think is the most efficient one, unless you're making like a better project. If you just want to view them, set them as 0, 0, 0, so they're in the center of your screen. The length we've set to 3, height 3, width 3. Of course, if you don't set these, they will just default to 1. And the color I've set to blue. So let's run this and see how it is. And all of the rest of these I've commented, which means that the program won't read them. It'll just skip over them. So we click F5, and we get our box. And here is our beautiful, magnificent box that starts at 0, 0, 0, extends outwards with a length, height, and width of 3, so it's technically a cube, if you want to think about that. But this is our box, and this is the basic way to make a box. And of course, there are so many different attributes. I will link the website. Again, I keep saying this, but I'll link the website for you guys to look at the other attributes you can use. Moving on, we have our cone. And I wanted to demonstrate with the cone a different way. If you want to work with this cone, not just to have it print out, you can, and you want to do other stuff to it, which we'll do later, but if you want to just do different stuff with it, you can define it as a separate variable. And that way you can call it later in your program, just like we call variables and define them in Python. But here we have our cone. We've positioned it. The vector is 0, 0, 0. The axis it'll extend outwards is this. The radius of the base is 3, and its color will be red. And here, I will show this a little bit later. I'll actually delete this for now. It's something cool you can do with it. But let's run it and look at our amazing cone. So this is our cone. Of course, we'll want to rotate it a bit. This is just the view that it gives us in. And this is our amazing cone. Here has its base with the radius of, I believe I said 3. Yes, 3. And you can rotate it around just like I said before. And that's how you make a basic cone. Here I want to show how you can use materials. So material is just you can make it like steel, wood, whatever. There's a bunch of ones that are default already built into vPython, or you can import your own. But for now, we're just going to use the wood, which is a simple built-in one. We're going to click F5, and it's going to give us a wooden. Oh, whoops. You want to type in materials, not material. My bad. So you type in material equals materials.wood, F5, and you rotate it around, and it's a wooden material. And that's really awesome because this means you can create like a house in vPython. There's endless possibilities. So I hope you guys look into that. Next up is our cylinder. Our cylinder I've made white. We're going to make it start. I've just been demoing these for you guys. I could just link you guys to this document, but I wanted to show you guys how these work. Our cylinder starts at 0, 0, 0, the center, then its axis that it extends up and down from, or side to side, whatever direction it extends from, is 5, 0, 0, and this will be sideways because, of course, this is an x-coordinate that's being changed. And our radius is 1, and our color that we've set, or I've set, is white. F5, and this should give us a horizontal cylinder with a radius of 1. We could rotate it, as I showed you guys before, and here is our magnificent cylinder. And if you guys set it to a different point, it'll rotate around that point. Right now it's rotating around 0, 0 when I rotate it, but otherwise if you just offset it, it would rotate around a different point, of course. Here we comment cylinder and we move on to our next one, which is the ellipsoid, which is basically an ellipse. I don't know why they call it ellipsoid, but ellipse. The center will be at 0, 0, 0. The length will be 3, height 8, 2, width 2. And of course, I've just made up these values. You could, of course, change them, but this one works out really well in the small window. We've set it to color yellow, and let's see how it turns out. F5. And here is our beautiful ellipse. It starts at 0, 0, extends with the height, width, and length that I said, and it is yellow. Yet another color that can be used in vPython. Okay, next we comment that, and we have a helix. And a helix is really neat. I'll actually go to the PowerPoint for a sec, but the helix, and of course all of these have links attached to them, but you guys can just find it at the main link that'll link in the description. Here it says navigation, which I already went over, but let's start with the helix. The helix is basically a spiral, and it looks really, really cool. It looks like a spring, and we want to position the center, or it to start spiraling from 0, 0, 0. Then this is the axis, or the vector. -1, -2, -3 is the vector across which it will spiral around. The radius of 2, how large the coils will be, and the color will be orange. So let's go F5. And here we have our amazing spiral. It starts from 0, 0, spirals with a radius of 2, and it's along the axis that I defined. And to find the axis, you can just do a basic vector addition. It's basically a coordinate in the X, Y, and Z planes. Pretty self-explanatory, I hope. But I think that is one of the coolest ones of the shapes. I really like the helix. And now I'm going to actually move in to label and text. And this is, you can make text in vPython, which is really cool if you want to label or just have text in it. But the difference is that label will surround your text with a box. Text will just type it out, but label will type it out with a box around it. And let's see the difference. I will demonstrate it here. Let's uncomment label. So we uncomment labeled, and you can change your text, font, whatever. F5, we're going to make it a magenta color. By the way, vPython does not, you can't type in purple here, you have to type in magenta, as I have learned from experience. Because purple is my favorite color and they didn't have it. You have to type in magenta. So sad. But F5, and here we get the label of Girls Code It is amazing in our magenta letters and with a box around it. And I just wanted to demonstrate, and here it's centered at 000. I wanted to demonstrate how you can change it to a different font. This is right now this font. You can import fonts or just use the default built-in ones from vPython. I'm going to use the built-in ones because I don't have time to import, but we can change it to this separate font. And if we click F5, it'll give us a different font. See? It's a much smaller, different font. Okay, and that, as you guys saw, and you guys can change the text here. Girls Code It is amazing, which is why I put that in the text. I hope you guys join our classes, subscribe to our channel, watch our videos, so on, so forth. But it starts at 000. Then, if we comment this, and we go to text, I would just want to show the difference. But text, text will, here, wait, I'll just show you guys. Text is green. And here I've aligned it left, but it doesn't have the box around it, which is what is different. And I hope you guys see that. It's pretty evident. No box, no label. If we want to align it a different way, here we can just type in center or right. If we type in center, it should put it in the center without us having to define it as a vector for its starting position. And of course, it puts in the center. Big words, subscribe to our channel. Make sure to follow what vPython is telling you guys. Subscribe to our channel. Alrighty, moving on from text and labels, we have our pyramid. And this is just another shape I wanted to show. This color is just a very light blue. I have no idea how to pronounce it. Please don't laugh at me. But this color is a light blue. We have it at a starting position of 000, as we've had all the rest. F5. And here's our pyramid. Of course, we have to zoom out a bit because you can't really see it. So if you click Alt and then you drag the mouse down, then to rotate, Shift, right-click, and rotate. And here's our beautiful pyramid. It's a light blue color. Alrighty, next shape, we have points. And points are really useful if you want to just like show a graph in Python or in vPython maybe, or just have like a scatter plot, different points, or just have points everywhere. I don't know, if you want to make like a connect the dots type thing in vPython. Sounds fun. You guys should try that. But points, we define their where the point we want it to be located, its size, and we define its color. And if we click F5, it'll give us a point right in the center at 0, and its color will be red. And if you just want to make multiple of these at different origins, just define it at like 100, which will be like here. And then you just can keep going like that to create a connect the dots game. Our next one that I want to talk about was the sphere. And the sphere, I wanted to note how we have a position, radius, color, size. So why have radius and size? Why did I put that there? The truth is you don't have to do this. You can either use one. I just put them here so it's easier for us to for me to show you guys. But if you put both of them, the program will still work. vPython will just default to the first value, and it will not pay attention to this value. So if we run this, it should give us a sphere with a radius of 5. And if you guys want, it's a good opportunity, since I don't have enough time, but to try just this one, and you'll see that it's a different sphere. Make sure to delete this one, of course, but right now it'll default to radius equals 5. So and of course we have our starting position here. F5, and it should run and give us a beautiful, magnificent egg-like sphere with a radius of 5. If we want to zoom in or out, but we just drag our mouse down, while pressing the Alt key, and here's our magnificent sphere that we can use, let's say, for a bouncy ball in the box. Commenting that, we move on to the last thing I wanted to talk about, which is, I'm going to go back to the PowerPoint for a second. So here, as you guys can see, I actually didn't go over the curve from the last slide. So make sure to look at that. It's really useful if you want to make a curve. I just didn't have enough time to cover it. But if you want to, I didn't go over lighting either. So make sure you look at that too. This is pretty neat. In vPython, it's a nice feature. But if we go on, the extra features include such as textures. Materials, which I showed you, is very similar to textures, which is why I didn't show textures. I thought materials would be cooler. Textures is also really cool, so you guys should look into that. Clone will just clone your object. It'll make the same one, but a different object if you want to manipulate or change that object, but save the other one. This is really useful. Rate will change the rate at which your animation is completed, and angle is the one I wanted to show. Angle will actually rotate your object. So if you put it, you want to have like C, rotate angle, let's make it like 170 degrees. And we want to rotate this object. Make sure to uncomment this if you're going to uncomment C, because we've defined this object here. We don't want it to just call in a random object that we haven't created. So it'll rotate it 70 degrees. So F5, 170, sorry. And here our pyramid is rotated. And it's not really visible because it's so close to 180, but you guys should play around with that too. Here we have our wooden pyramid, our red wooden pyramid, rotated at 175. And it'll rotate it around the axis that you define for it. So make sure to uncomment this so it has an axis to rotate around. Let's close this. Yeah. And we comment this. And let's comment that one too. And I just wanted to note how here we define this object as C equals. This is an example of how an object can be referenced, or a variable can be referenced later in the program. And that's really useful if you don't want to just print it out. And if you're making a more complicated program like the tutorial for a ball in the box, you want to define these objects beforehand so that you're not just having them print out and then not knowing what to do with them after that. Okay, so I think, let me check real quick. Awesome. Okay, we're on track. But here, as I explained, rate is, I don't think I explained this one. I'm going to explain it right now again. Sorry if I'm explaining it again, but this is the rate at which the animation performs. So animations such as the bouncy ball in the box, those will perform at a certain rate. So you just want to define your frequency that you want them to perform at. If you want it to go slower so you can, see how it's made. Trails is really neat. It'll show you the way that the object has traveled in an animation, or how it's made. So it'll have points appear, and it'll show you an arrow, like not an arrow, but like the direction of how it's traveling. So you guys should definitely check these out. I didn't get to go through a lot of these, but they're really cool. So I'm going to link this in the description, which is just more information on it, on vPython. And I just remembered that I forgot to note that you have to make sure to include this line at the top. This line is very important, because what's the point of using all these functions if you haven't imported them? Asterisk will allow you to import all of them. I'm not sure actually if I went over this. Sorry if I'm going over it again. But it'll allow you to import them. You don't want to import them all separately. That would make no sense. But here in vPython 7, this is a tricky thing, because in the document, if you guys noted, it says that you have to import vPython, but we're importing Visual. So this is an example of how different versions conflict. So you have to make sure to know what works for your own version. Asterisk will import everything. Make sure to include this line in order to actually be able to use these functions. And of course, I'd like to especially thank our volunteer Kennedy for making us this presentation. Thank you to the sources that she used, which is this link that I'll link in the description that has a lot more information that covers this. This was basically going over some basic shapes. I hope you guys found it helpful, but this is more in depth if you want to create a project. And as I'm going to link this in the description, but this is a bouncy ball in a box tutorial created by our volunteer Kennedy. This is one of the many projects you can create in Python. Here I'll show the code for it, how it looks. We want to open, and if you download it from here, it has pre-made code for you. So you can click open, click bounce 2, which is the bouncy ball in a box. This is all the code for it. And we click F5 to run it. And look at how cool it looks. It's so mesmerizing. But basically this, you have to know about colors, about the spheres that we talked about boxes for the walls, the trace here. And you have to know how to offset these so that it looks connected, right? So I hope you guys look into this more and create some fun projects such as this one. Look at the tutorial video. It includes all the code necessary for this with explanations. Alright, I think this concludes our lesson. So, of course, thank you so much for being here with us. Our next STEM session 6, will be a live Zoom call with some of our volunteers who are in college, and they will talk about their experiences, and you guys will have a chance to ask them questions. So make sure to attend that one. Of course, check out our website. We have courses that are ongoing. Check out our channel if you can't make those courses to watch them recorded. Right now we're doing Python. Make sure to sign up for the web dev courses that are coming up sometime in late November, early December. And yes, thank you so much for being here. Make sure to look at some of the previous STEM sessions. I hope this tutorial helped for vPython. I hope you guys are interested now to see what vPython can do and how many projects you can create with it. Make sure to check out this tutorial. Thank you for supporting us. Oh, and make sure to subscribe to our channel. vPython tells you to subscribe, so make sure to subscribe. So thank you guys, and hope to see you all soon. Bye guys.